Hello, my name is Rico Tyler and I'm with the National STEM Scholars Program, bringing you new ideas on how to bring phenomena-based science, sense-making, and claim evidence reasoning into your classroom. Today's topic is magnetism. Specifically, there's a next generation science standard for 7th grade that speaks to students having the ability to ask questions about data to determine the factors that affect the strength of electric and magnetic forces. Interesting topic. The problem is, how exactly do you get students to collect data that they can make these kind of determinations from? Magnetism is an easy topic to look at, but how do you actually turn it into something that's quantitative? Here's a magnet, little button magnet, metal object. And I can play with this magnet, moving it close to my metal object to see just how close, there it picked it up. But how do I actually measure these distances and change the amount of magnetism so that I can get data that my students can use to make determinations about how distance affects the strength of a magnetic force? And I want to do it in a simple way. I don't want to have a lot of complicated equipment that get in the way of my students understanding what's going on. And today we're going to show you a way to do that. And to do that, let me show you what I've got right here. This is my actual kit that I do this activity with. And in here are some magnets and actually a bunch of playing cards. Let me show you how this works. What I've got here, if you're curious, these little containers are actually nickel containers. Great way of storing magnets. These are some button magnets. Very typical, ordinary button magnets. You can pick these up in most hardware stores. Craft shops carry these. They're very inexpensive and you need 10 of them to do this experiment. You also need a metallic object to pick up with your magnet, and I like using hex nuts. This happens to be a 1/2 inch hex nut. You could do this with 1/4 inch hex nuts or anything else that you have available. The next thing you're going to need, and this is the key to this experiment, is you need a deck of playing cards. Now after you see how this is done, you're probably going to realize you could do this experiment with index cards. But I think playing cards have some advantages, and I'll talk about that when it comes. The purpose of this experiment is to see what effect distance has on the ability of a magnet to pick up a hex nut. So here's how it works. We'll start with one magnet, which can obviously pick up a nut. We're going to use the index cards as a ruler, actually, to see how far away this one magnet can pick up this one nut. So let's start with 10. Can this magnet pick up the nut from 10 cards away? So put the nut, if you put the magnet on top. Yes, it can. So the index cards become our way of measuring distance. So if it does it at 10, let's do 5 more. Can the magnet pick up the nut from 15 cards away? And I tend to squeeze the cards a little bit to make sure that they're nice and flat. The answer is yes. So if 15 works, let's try 16, 17, 18. If you notice, I'm standing up the nut to be consistent each time. It works at 18. Does it work? 2 more is 20. Stand our nut back up. You can tell it's trying to pick it up, but not quite. So 20 is too many. Let's see if 19. I've done this before, I know 19 works. So one magnet can pick up one nut from 19 cards away, and this is the key. This is our measurement, our unit of distance. We know that one card, or one magnet, 19 cards, picks up one nut. So what if we change the situation and try 2 magnets. How far away will 2 magnets accomplish the same task? Well, your first thought's going to be, if 19 cards away is how far 1 magnet can do it, you're probably thinking it's going to be twice that, or 38. So let's pick up another 19 card. As I said before, you can do this with index cards, but they're not easy to handle. And I find that students find this easier to do. So this is 19 and 19, 38. Will 2 magnets pick up a nut from 38 cards away? And the answer is no. In fact, it's not even close. So if 38 doesn't work, let's take away 37, 36. Let's see if it works at 35. No.
34? 32?
There. Just barely. And that was, let me double check my numbers, 27. So, while 1 nut can be lifted by 1 magnet from 19 cards away, it's only 27 for 2. It's not double like you expect. And let's check this a little bit further. Let's try 3 magnets. That was 27, 28, 29. Let's see 30. Not even 30 at this point. No. With 3 magnets, we only got to 29 cards. If we try 4, there's 30 cards. Okay. Will it make it to 31? 31. Let's see about 32. Nope, it's 31. Notice that each additional magnet seems to be having less and less ability to lift the nut through the cards. Now, I've done this all the way from 1 to 2, 1 to 10, and I'm going to show you what that looks like on a graph. Here's what it looks like. Now, the numbers are slightly different here because with different trial, but you can see very easily that each additional magnet is adding less and less ability to separate the magnet from the nut. Until you get out here near the end, 8 magnets only lifts 34, 9 only 35, 10 magnets only got to 36. And I've added a column here which divides the number of cards by the number of magnets. This gives you kind of a relative idea of how well the magnets are working. When we had 1 magnet in this particular trial, we were able to lift the nut through 17 cards, which is 17 cards per magnet. But with 10, we're only doing 3.6. Distance makes a dramatic difference in how well a magnet can pick up a nut, because magnetism follows something called the inverse square law. Every time you double the distance between a magnet and something it's trying to pick up, the force is decreased by 2 squared, or 4. Magnetism gets dramatically weaker with distance. And that's the point that I want my students to see. Now, if they understand this, then what can we do to see if they understand it in terms of doing something for us? And that's why we have a second part to this activity, which is an elaboration. And the elaboration goes like this. Let's start with an entire deck of cards and our original nut. And here are the 10 magnets. We know that 10 magnets won't pick up the nut through an entire deck of cards. But maybe we could pick up the deck of cards with the magnets. So if I take half the magnets, put them right here, put our stack of cards here, and the other half here, can I pick up the top magnet and pick up the entire deck? Well, no. There's just not enough. The magnetic field is just not strong enough to hold the deck together. So what you do here is you have students, give students their magnets, give them a deck of cards, and see how many magnets it would take to lift the entire deck. Now I've done it by trying to put 5 magnets below the deck and 5 magnets above the deck. But I tell the students they can use any kind of arrangement that they want to. The key is we've got to keep the magnets close to each other. That way they'll pull with their greatest force. So here's one way to do it. And of course I wouldn't show this to my students, I'd let them try different ways. But what I'm going to do is take my deck, split it in half, kind of by eye, and then split each of those decks in half, like so. And now I'm going to try to do it with only 5 magnets. Put the first one here, put 1/4 of the deck, put a magnet, and let's put another 1/4 of my cards. Put that right there. Then here is another stack, and when I put the magnets on incorrectly, nature solves that problem by flipping it over for me. And now the last bit of them, like so. Now I've got an entire deck of cards, but I'm only using 5 magnets. So if I grab it from here, I can grab the entire deck with only 5 magnets. And what I'm doing is I'm taking advantage of the fact that if I keep the magnets close to each other, their pulling strength is much greater. This gives you a second activity within a lesson to test students' understanding of the concept that hopefully they understood from the first activity. And there are other ways that you could do it as well. In fact, you could do this, I've done this very same part to the experiment by starting with 4 or 5 magnets and asking students how many cards can they pick up with X number of magnets. In each case, what you're trying to do is see if they understand how to maximize the magnetic force by minimizing the distance. I hope you found this activity a useful addition to your classroom, a way to get students to think about magnetism in a quantitative way and not just in a qualitative way. Thank you for watching.